All right, next part of the notes, we've got number 6. Since 1990, fireworks usage nationwide has grown and shown in the accompanying table, where T represents the number of years since 1990, and P represents fireworks usage per year, millions of pounds. Number of years since 1990, years, that's going to be our X. This one will be our Y. Remember, the X's go in the L1, the Y's go in the L2. Now, before we plug this in, if you go to Stat and Edit, we have our L1 and our L2 filled up, so we got to clear it out. So if you go up here to L1, push Clear, and then push Enter, it'll erase everything. Do the same thing for L2, and now let's plug it in. So I've got 0, 2, 4, 6, 7, 8, 9, and 11 for my X values. Now for my L2, my Y values, 67.6, 88.8, 119.0, 120.1, 132.5, 118.3, 159.2, and 161.6. Once you have all your data in there, just go back to Stat, Calc, Linear Regression, and go down to Calculate. Since we have in our settings from earlier, we'll get the strength as well as the equation. First, it says write the equation and round your values to 4 decimal places. So our equation is y equals ax, our a value is 8.1847, and then 74, and then that 8 meets the 4 round up. Oh, sorry, 5 places. Or sorry, 1, 2, 3, 4. Yeah. So 8.1875x plus, and our b value is 72 point, and my 4th place is that 0, so that 3 means it's going to stay the same. So 786. And you can put the 0 if you want, but we don't really need it. Now, it says use this equation to determine what year the fireworks usage would be 99 million pounds. Well, what we'd have to do is 99 million pounds is going to be the Y, because pounds is the Y. So we'd have 99 equals 8.1875x plus 72.786. And we've got to figure out what x is. So what would we do? Move our number over here and then divide by this value. So 99 minus 72.786 is 26.214, which should equal 8.1875x, and then divide by this value. And we get our x value to equal 3.201. So it's going to be that's going to be during the 3rd year, year 3, which is, they started out in 1990, so year 3 is going to be 1993. All right, now we've got another one, number 7. Says, table at the right shows the average rate of hearts, which represents the linear coefficient between their age. Once again, Stat, Edit, plug in our information. So this is going to be our X's, this will be our Y's, so that's our L1s and L2s. I'm going to clear, enter, and then type them in. So 20, 30, 40, 50, 60, and 70. L2s is 135, 129, 122, 115, 108, 102. And then stat, calc, linear regression, go down to calculate, and we're looking for the linear coefficient. So it's going to be the R value. This time it is negative 0.9996. So this tells me it is a strong negative relation because it's almost -1. Now our last one, we have data set of numbers. Sorry, I'll scroll down to where you can see it. We want to know if it's positive or negative and weak or strong. Well, the first values are x's, the next values are y's. If you need to set up in a table first, you can, but I'm just going to plug it in as is. So I'm going to go stat, edit, clear my L1s, clear my L2s. And L1 is going to be 1, 2, 3, 0, 8, 2, 6. Now we're looking at our y's. So it's going to be 0, 3, 2, 9, 3, 5, and 1. So I've got my x's and my y's in there. Stat, calc, linear regression, go down to calculate. And we get our correlation coefficient, our R, is equal to negative 0.397. And we're going to determine if it's strong or weak. Well, if it's strong, it would have to be close to -1. It would be above -0.8. So this one is going to be a weak negative because it is less than 0.5. So that is it for the notes. I know it was a lot. I hope you have a calculator to practice on. If not, you're going to need this skill when you come back. So review the video as much as you can. There's no assignment attached with this. It was just a practice with the notes, okay? I hope that you learned something.